Today we're going to be learning about pictographs and pictographs. So let's get started. So here is an example of a blank pictograph. So first of all, let's take a look at the title. The title of this pictograph says, Teacher's Favorite Ice Cream Flavors. Then we have two columns. On the left, this column says the different flavors of ice cream. On the right, we are going to be showing our data of how many people like chocolate, how many people like vanilla, strawberry, and chocolate chip cookie dough. So, looking at this picture graph, our data shows that 5 people like chocolate, 2 people like vanilla, 2 people like strawberry, and 3 people like chocolate chip cookie dough ice cream. So let's go over what words we need to know to be able to understand pictographs and pictographs. So the first new word is data. Data is simply just information that we are looking at or that we are analyzing. So the data in this pictograph would be the number of people that like each flavor of ice cream. And then the next word we need to learn is analyzing. Analyzing means that we are trying to understand or answer a question. So for this data, if we're analyzing it, we are trying to figure out which flavor of ice cream is most people's favorite. Next, all of this information is shown on a table. So this, what looks like a chart here, where we have the title and we have the different flavors of ice cream and then the number of people who like it. This is called a table, and a table is where data is shown. A table is also where we are going to be making our picture graph and our pictograph. And I know it's complicated because I think in the past, people typically think of a table as something that you eat off of. But in math, like I said, a table shows data. Next, we're going to talk about how do you create a pictograph. So first of all, you have to collect your data or your information. So you would typically do this by sending out a survey to people who you want to collect data from. So here's an example of our survey. Maybe I would give all the teachers at Burnside this survey that says, what is your favorite flavor of ice cream? And then they can check off if it's chocolate, vanilla, strawberry, or chocolate chip cookie dough. Then, once you have received all of your data, so once people have returned their surveys to you and you have your answers, then you are going to analyze your data or analyze the information. So after analyzing the information, let's say I found out that 5 people like chocolate ice cream, 2 people like vanilla, 2 people like strawberry, and 3 people like chocolate chip cookie dough. So I can analyze that to figure out what is the most popular flavor of ice cream. That would be chocolate. Or what is the least popular flavor of ice cream? That would be a tie between vanilla and strawberry. Then you are going to take that information and put it into a picture graph or a pictograph. Right here we have a picture graph. So before, I just had the number of people that liked each flavor in tally marks. But in a picture graph, I'm going to use pictures to show each person who likes a specific flavor. So this picture graph shows the same information, the same data, just in a different way. So instead of a tally mark, I have a small picture of an ice cream cone. But it still shows that 5 people like chocolate, 2 people like vanilla, 2 people like strawberry, and 3 people like chocolate chip cookie dough. So now here is the difference between a picture graph and a pictograph. Do you guys see the difference? Let's go back. Here's a picture graph, and here is a pictograph. The main difference between these two is that a pictograph will have a key. The key will show you what each picture represents. So here's where a lot of people make kind of a silly mistake. So this key says that one ice cream cone equals or represents 2 people. So if that's the case, how many people liked chocolate ice cream as their favorite? Let's see. We have 2, 4, 6, 8, 10. 10 people liked chocolate ice cream as their favorite flavor. How many people liked vanilla? Let's count. 2, 4. So 4 people liked vanilla as their favorite flavor of ice cream. How many people liked strawberry as their favorite? Let's count. 2, 4. So 4 people liked strawberry ice cream as their favorite. Lastly, how many people like chocolate chip cookie dough as their favorite? Well, let's count. 2, 4, 6. 6 people liked chocolate chip cookie dough as their favorite. It is super important to pay attention to the key, because if you don't, you will not understand or be looking at your data correctly. Because if you think about it, using this pictograph, for example, 10 people liked chocolate ice cream. But if I did not look at the key, I would think that only 5 people liked chocolate ice cream. And then I would get a lot of my information wrong. So let's read these directions. The results of a survey are shown in the picture graph below. Use the results of the picture graph to complete the pictograph. Draw the juice boxes in the pictograph to show the data. So again, the difference is that we are going to use a common picture. So we're going to use a juice box to show how many people had apple as their favorite juice, orange juice as their favorite juice, or pineapple juice as their favorite juice. And if you look at the key, it says that 1 juice box is equal to 2 votes. So the first thing I want to do is figure out or count how many people liked each flavor of juice. So after doing that, I have found that 4 people like apple, 7 people like orange, and 7 people like pineapple. So on this pictograph, since 1 juice box is worth 2 votes, that means that I have 4 people like apple juice, 2, 4, 6, and hey, what does this half of a juice box mean? What do you think? Well, I know that if 1 whole juice box means 2 votes, then I'm going to take half of 2 because I took half of the juice box. And that means that a half of a juice box would equal 1 vote, which would make sense because if I do 2, 4, 6, 7, that would match my data. Same for pineapple juice. 2, 4, 6, 7. Again, that matches my data. All right, this says a scientist is doing a survey on butterflies in a local park. She records the number of butterflies seen on different days. She saw 8 butterflies on Monday, 18 butterflies on Tuesday, and 16 butterflies on Wednesday. Use the information to complete the pictograph. So first, I'm going to organize my thinking. And I'm going to show those numbers, the data, using a tally mark. Now I can think about how I'm going to make my pictograph. So if I take a look at the key, it says that 1 butterfly would be, 1 picture of a butterfly would equal 4 butterflies. So for Monday, that means if we have 8 butterflies on Monday. But let's count by 4 until we get to 8. So we have 4, 8. So that means that I would have to have 2 butterflies for Monday. Then you'll notice that for Tuesday we had 18 butterflies. So let's count by 4s. 4, 8, 12, 16. Now, if one butterfly equals or represents 4 butterflies, half of a butterfly would equal 2. So again, we have 4, 8, 12, 16, 17, 18. So that matches our data, right? 18 butterflies. On Wednesday, we had 16. So let's count. We have 4, 8, 12, 16. Again, that matches our data. 15 students drew pictures of their favorite fruits on sticky notes. Their responses are shown in the picture graph. How can this data be displayed in a pictograph? So again, the difference between a picture graph and a pictograph is the key. And you are going to use a common picture. So for this picture, it looks like they're using a bowl of some sort. So, and they added the key. So one bowl equals 2 students. So how many people like bananas? We have 2, 4, 6, which matches how many we had here. 1, 2, 3, 4, 5, 6. How many people like oranges? We have 2, 4, which matches our data. 1, 2, 3, 4. How many people like strawberries? Well, that would just be 2. Again, matches our data. 1, 2. Next, how many people like apples? Well, we have a half of a bowl here. And remember that if a whole bowl represents 2 students, a half of a bowl will represent, what is half of 2? Half of 2 is 1. So this would be 2, 3, which again matches our data. So to answer their question, half a basket represents 1 student. And then there are half as many symbols in the pictograph as the picture graph. So the graphs display the same set of data in 2 different ways. Next, we have our last example. So this says, when you read a graph, you study or analyze, which means you look over, you study the data. Then you are able to interpret, that means understand the data or explain what you learned. The pictograph shows the results of a survey Antoine conducted. Who saw 2 more movies than Grace? So when I'm looking at a pictograph or any graph actually, first I'm going to read the title of the graph. This graph says, movies seen during summer vacation. And then I'm going to read this information. So Zach, Carla, Grace, Ivan, Ricardo. So I can infer, I can figure out that those are the name of the people who they surveyed. Then each movie ticket represents 2 movies. So next, I'm going to figure out how many movies each person saw. I like to write that information here on the graph, just so I don't forget. So if each movie ticket represents 2 movies, and I have 2, 4, 6, 8, 10, 12. So Zach saw 12 movies. Carla saw 8. Grace saw 6. Ivan saw 12. And Ricardo saw 6. So then the question is, who saw 2 more movies than Grace? So if Grace saw 6 movies, 2 more than 6 is 8. So who saw 8 movies? The answer would be Carla. Carla saw 8 movies. Do you see why it is super important to look at the key? If you don't look at the key, you would think that Zach only saw 6 movies, and that's not true. So it's super important that you pay attention to the key. I hope this makes sense. If you have any questions, please ask.